So this project is like a continual yak shave that has just not stopped. The initial idea with it was to make like a live chat bot. So basically like a chat bot like you would have on the screen, which I made that separately. But then the idea with the robot arm was to like make like a puppet that you would have like the mouth operated by the gripper. So that was the initial idea, but then once I actually like built the little SDK thing for it, which I'm about to present, then I thought that was actually more fun to like drive it around with the controller. So and also the gripper is a little bit too small to be the mouth of the robot, so it didn't really work out as like what I had intended for it. But I ended up with this robot arm through my work, through like this so-called cool projects thing. And so I thought, well, yeah, let's go for it. And so this whole thing has been like a massive yak shave. So what comes with the robot arm is sort of a janky SDK from that's in Python, and the company has kind of low-key support for it. Like there's a bit of an SDK, but it's nothing serious. So I started off with this robot arm, which you can see here, which you can look it up online later on. It's a Waveshare RoArm MS2 or something like that. There's links in the presentation as well to like the library, which you can look up later. One of the nice things about it is that it's like a fairly accessible robot arm that for about $300 you can get a fully functional robot arm. It doesn't have a wrist, but it has 4 joints. So basically like a gripper, an elbow, shoulder, and the shoulder rotates in 360, etc. So for $300, it's like pretty good for you know, what you want. So we got like the slightly janky version of RoboCop instead of the actual RoboCop, but you know, it's good enough and it's still fun. And for $300, it's a fun lark. So at the beginning, we got stuck with Python, and I just don't love Python. I mean, I don't hate it, and I think that there are people that can use it to great effect. But I just want to write Elixir. That's all I want to write in. And so now that we have Claude, we can just say point it at that thing and give me an Elixir SDK back. So that's basically what I did. Also, the thing has an SDK that's a part of it. The SDK has like an API where like you can deliver packets in JSON to it. And so it does have a fairly rudimentary API that you can basically use. It has like, it projects a Wi-Fi instance. So like if you connect to it, you're connected to it instead of through your router. So effectively you're like disconnected from the world unless you have like a secondary Wi-Fi card or you have like a physical connection or something like that. So I just didn't like that option. So I used circuits in that's a part of nerves. So let's just take a look first about what we're replacing, which is this SDK. Which I think I had a link there. Yeah, there's a link. So this is the RoArm's SDK, which is like, you know, it's fine. And there's a picture of the unit. This is the little crappy one that I got, and then the slightly better one, which would be probably what I would recommend getting because it actually has a wrist, so you can have a little bit more mobility. But my SDK would actually run both of them, I think, because I basically like followed theirs, which accommodated that as well. So we started off with Python. I don't want to write Python. I thought, oh, I'm kind of limited to this web interface thing, which kind of terrible because it cuts me off from the world. But yeah, so the idea is, can we just take this and reverse engineer it? So I give it over to Claude, and away we go. So basically pointing Claude at it, it can reverse engineer the all the commands that you need to do, and using circuits in nerves. I don't know if anybody's ever used circuits before. Circuits.UART. So UART is a protocol that's over top of USB, and it has like the baud rate and all those types of things that you would expect with like that kind of low level stuff. But yeah, that's fairly simple once you have all the specs that you need, which, the original Python SDK had all those specs. And so you just, strip mine the Python thing and replace it with the Elixir thing, and away you go. So without too much bother, I had a working SDK, not that one yet. Well, I had a working SDK without a lot of effort, where it was doing something. So like you push buttons or you give it commands and the robot arm does something, and maybe it does the wrong thing, but then, by iterating with Claude, you can just go back and forth and be like, oh, well, that's what it did. Claude has no way of understanding what's happening in the real world. So I'm like the real world, I'm Claude's eyes and hands in the world. So basically by iterating between myself and Claude and the robot arm, it's like you can figure out what's happening. So that's for the documentation. So at this stage, it was very helpful if you guys go to the website that I linked, which if this ends up on YouTube and people are looking at it on YouTube, I can't guarantee that the website will still be there. I don't plan on supporting it long term. I'm not going to have this robot arm set up in my bedroom for the indefinite future. So, but if you went to that website, you can look at the demo that I put together. So basically, by using the demo as like an interface and then building the SDK at the same time, that was what kind of like really helped me drive it forward, because essentially you want to have like a visual representation of what your code is doing, and it's hard to just look at server logs all the time to be able to understand what's actually happening. So by doing that visual interface, that was a big game changer for me. Also, like the analog sticks, for example, that was the type of thing where you say, I think I know how this works and conceptually how it works, but I need to see like a visualization of how it works. And if I was having to read that off of like terminal logs, that would just be like a very painful experience. So by putting that type of thing in the interface, then that helps me to iterate much quicker. Yeah, so basically all the things with Elixir makes it like really seamless. Crashing is painless, so it's not that big of a deal. Okay, so the next step, once you have some sort of an SDK built and you wanted to publish it, is that you can then put it up on Hex. I don't know if people here, we can do like a show of hands or something, people here that have actually published to Hex before, but it's actually really easy. Like we can talk about it more later or something, or people can interrupt and just say what their experience has been with it, but it's super easy. So essentially, and when you have Claude there, you can basically just say document as you go, and you've already got the docs built by the time that you're actually built the thing. And because Claude does better when it has something to go off of more than just the code, but something that explains it, that's also what makes it very helpful, or like much more seamless experience of like you have the docs help Claude, the docs help you. And then by the time that it comes to publish, you just hit mix doc, and it cranks out your docs, and then it's like I think it's mix hex.publish or something like that. But it's super simple. Like the team has done a great job of making it so that actually kicking out a library is pretty seamless. So obviously with Claude as well, you want to keep the tests up. Like as you go, you want to build code and then test, and then build code and test to make sure that all of your code is tested, especially if it's something you're going to put out as a library, that make sure that it has some decent tests. So yeah, now I'm published. So mix hex.publish. There's a library now called roarm. If you go to hex.pm /roarm or whatever it is, you can see the thing that I put out there, which I know it's super niche, where it's like one robot arm, or like this robot arm and one other one. I understand it's super niche, but that's fine. And I don't think I'm like camping on anybody's name by calling it roarm, so it's not a big deal. Yeah. So if any questions, by the way, just jump in. I realize that I can talk a lot, and that's not a problem. But any questions, you can jump in. So yeah, the documentation is here now. So yeah, Hex.pm RoArm, and I'm on my second iteration, which was a couple of minor kind of polish up things. If you're going to use this, the things that actually work are the like directional commands, the X, Y, and Z commands, which are like part of the built-in library. They don't work that well. They're pretty random, which is unfortunate. So that would take a lot of tuning. If I went back and wanted to, like, say, do a different type of thing where I actually wanted like X, Y, Z coordinates, then I would need to go back in and tidy that up. So that's another thing that I would say is like, if you put out a library that's useful for your own purposes and it covers like the thing that you wanted to do fairly squarely, just publish. It's okay if it's not like, you know, covering 100% of everybody's use cases. So this RoArm demo thing, that's also on my GitHub. If you're interested, you can go look. I think there's links in the presentation later. So that's basically this thing that I'm presenting that I put at rowarm.boltbrain.ca. Yeah, so by having that and iterating back and forth, that was extremely helpful and useful. And if I was to, so, you know, I didn't intentionally clickbait you with nerves. There will be nerves at the end, I promise. But if I went straight to nerves, where I was like, oh, I want to make this thing run off a Raspberry Pi, then it would have been extremely painful. Like actually getting to the point of having a working like SDK and having this browser thing go back and forth, that was like pretty seamless. And then it was actually like, oh yeah, it should be no problem to just like chuck nerves on top of that, right? And then it was, yeah, it wasn't. It was a lot of difficulty, and the whole iteration process with nerves takes a lot longer because you're isolated, right? You're onto the other device, and so actually like delivering it, like your iteration time is like at least a minute, even though it's pretty fast with nerves. So like that's fast for embedded to have like only like a 1 minute to get your thing delivered, but it, you know, with the web page, it's instantaneous. You just save it and it's like automatically, you know, comes back around. So that was very, very instrumental. So yeah, the live demo, we're already doing that. Sorry, I'm recycling this presentation if you can't tell. So next one is nerves, because hey, why not, right? So part of my goal here was that I could take this thing and just go to somebody's house or whatever, or to like a board game thing or something, and just bring the robot arm and clamp it to a table and then plug it into the Raspberry Pi, and then just, you know, play with it. Like, I don't want to have to go log on to a website, or I don't want to have to go do extra work in order to be able to actually drive the thing. So that was the whole point, is that can we make this robot arm portable, and like you just plug everything in, that way you go and it's fine. So that's where the Raspberry Pi comes in. This is my Raspberry Pi. Has a little clip on it because I broke the little retainer thing for the micro SD card.
I'll break the ice for a second and just say I love
Sure.
how distributed thinking made you think distributedly. You know, they're like, oh, I'll just move it around. You know, we don't need a centralization in a main database, and like, you know, most centralized programmers don't think like, oh, I'll just carry it around with me. Like, that's, at least I've seen like that with Erlang or Elixir people. That's just, we're like, yeah, whatever. We just distribute. That's
yes.
Yeah.
There are a lot of lessons that I have picked up from distributed stuff, for sure, and just computing in general, but in particular with trying to understand the whole latency aspects, and like, oh, we're going somewhere else. How are we going to support this thing?
To refine what I said, I think you wanted it to be distributed. You know, that was more of your thought. The intent was to distribute in that, to bring it with you, carry it with you, kind of. Yeah. Well,
yes.
Just breaking the ice with the question or interruption, I guess.
Awesome.
You asked
Thank
for
you
it.
so much.
Yeah.
I mean, I'm all about it. So I'm happy to have the interaction. Okay, so yeah, the thing that it started off with was this XYZ thing. Well, actually, it does both. The SDK covers both cases. It's just for it doesn't really work that way that well, and so then I wanted to make sure that I could control it with some other way. My computer is kind of freezing up a bit now, so hopefully we can still advance the slide. Can we advance the slide? Can you guys still hear me, by the way?
Yeah. Yes.
You can still hear me?
Loud and clear.
Okay. All right. My computer's kind of freezing up. That's the Linux doesn't love the whole graphical thing. Yeah. So next step is nerves. So with nerves, you can. Okay. So who came here to learn about nerves, and who has actually done nerves? Like reaction, yays and nays. Yes, we have one thumbs up. Okay, so nerves is incredibly convenient, especially like I don't know who if you've ever done embedded with like C or something like that, but it's a lot of work and it's very awkward and annoying. But if you do nerves kind of on the happy path, you end up with lots of really nice conveniences. So if you connect your nerves by USB, you can just go to like whatever your nerves thing is called .local. So in this case, my thing was this thing .local, and you can it presents a web page for you if you do it kind of like a certain way, but also you can just SSH in really easily. So this is also incidentally how you can get Claude to talk to your nerves device is by SSHing into the device, and you can get Claude to help you essentially with your whole nerves debug situation, but it still takes time. So with nerves, it automatically gives you this .local thing that if you're set up properly, it will show up as .local on your in your browser, but you can also really easily SSH into it. So without too much headache, you have a functional device that you can connect to really easily, SSH into, and you don't have to like say have another computer screen or something like that hooked up into the device, or whatever other way that you may have had to try to debug things in the past. Okay, so sorry, this text ended up a little bit small, but yeah, so the tech stack is, we've got the SDK, we've got the demo, we've got nerves. This is what I vibe coded this presentation with. So everything that I do, like it's sort of a joke within the Calgary Elixir meetup, is that I'm just vibe coding everything now. But yeah, that's what Claude thought we got accomplished. And yeah, so the lessons learned here are to start small and to start basic, and then build your way out. So like the further away you get from the core, the more difficult your life is going to be. And you want to try to cooperate between all the different things that you're building, and you want to get to a point where you have a usable feedback mechanism. So you want to race to the usable feedback mechanism, and then from there iterate back and forth on top of that thing. So one of the previous companies that I worked for was like a backend for a chat application, and one of the greatest productivity things that we actually had was like an admin panel in the backend that you can, like, I mean, everybody knows about this now, right? But like finding like what your metrics are, all these types of things to be able to understand, like, give me some feedback give me some usable feedback. So I'm not just looking at logs, but I'm actually looking at something that is potentially meaningful. So find out whatever way that it can be meaningful to you. So like whether it's the analog sticks or whether it's like requests per day or requests per hour or however, find a usable metric that is going to be useful for you. Because the further away that you get from that core, the harder your life is going to be, and the longer your iteration times are. So like with the nerves iteration, it ended up becoming kind of painful because it was removed away from the you know, the source of what I was doing. And yeah, you want to have as high observability as possible. And that's it for the presentation. So I don't know if you guys want to see like what it's like to flash nerves, or you want to, like, it's not that complicated and it's not that exciting, but like we can do it. It's just the other thing that was also really helpful was so with nerves, there's like nerves, I think it's mix.burn and mix.upload or upgrade. I can't remember, but you always have to do those one after the other if that's how you're doing it. So then if you could just combine them in a single mix task. So for me, I just combined them in a single mix task called mix.reup or something like that, or mix reup, and then it just runs them both. So then, you know, those type of things. I mean, people here probably already know about like combining mixed tasks and stuff like that, but those little things make your life a lot easier. So anyway, yeah, that's it. I don't know what people are interested in hearing about. Also, today I dove into Membrane, which I don't have this in the presentation because it's part of the presentation in a sense, where it's like if you look at this thing, the demo. Let's see if we can get it to come up. Okay, so that's the robot eye view. So there's my hand, just right there. Yeah, so today was the first time that I'd really seriously get given a shot at Membrane. I can't say that I know enough to be able to like feasibly advise, apart from that, like Elixir is easy, but Membrane definitely has a foot in each camp, where it's like the C part is really unstable, or it feels really unstable, and it's crashing fairly consistently. So there we go. We lost the view of it again. And like it recovers because of the Elixir. The Elixir sort of like restarts it, but yeah, it's actually very unstable. In a different project, I was using Python X, which is also kind of an embedded thing where it's embedding Python into your code, and I didn't experience nearly the level of instability that I had with Membrane. So I guess with Membrane, thoroughly test. There we go. There's my 3D printer. With Membrane, you want to thoroughly test. Okay. Are there any questions?